Hello everybody, it's Mr. Combs again. So in the last video we left off saying that mixed numbers and fractions are rational numbers. But let's talk about what other types of numbers are rational numbers. So what about natural numbers, whole numbers, and integers? Well, they are also rational numbers because they can be written as fractions by placing them over a denominator of 1. We can do this because dividing by a number by 1 doesn't change it, right? Anything divided by 1 is just that number. So the natural number 5 is a rational number because it can be written as 5 over 1. So all natural numbers can be written as a fraction. So all natural numbers are rational numbers. The whole number 0 is rational because it can be written as 0 over 1. And all whole numbers, which include the natural numbers, can be written as a fraction. So they're all rational numbers. And the integer -8 is rational because it can be written as a fraction. And so all integers, which include the whole numbers and the natural numbers, can be written as a fraction. So in the case of rational numbers, we know that fractions, natural numbers, whole numbers, and integers are all rational numbers. But what about numbers written as decimals? Certain decimals are also rational numbers. And there are 3 types of decimals that you usually have. Decimals that terminate or stop after a while. So 7.889 stops after 9. So it's a terminating decimal, or it's a decimal that terminates. Decimals that repeat, so 2.353535353535353535 and continuing on forever is a repeating decimal. So it never ever ends, but it repeats the same group of numbers, which we call the repetend. So in this case, 2.35353535, 35 is the repeating part, so that's called the repetend. So 3535. And this is the way that we normally represent decimals like this. We put a line over the repeating part. But then there are decimals that do not terminate or repeat, like 8.1234, 23435564622. There's no repeating pattern. There's no set of numbers that repeats over and over again. And the ... leads me to believe that this decimal will never ever terminate. Alright? So only 2 of these decimals will be rational numbers, and that's 1 and 2. So these are the only rational numbers. The third kind, or the third decimal, will be a different kind of number we'll talk about in just a minute. So let's prove that. Let's show that decimals that terminate or repeat are rational numbers, that we can represent them as fractions. So remember, the way to show that something is a rational number is to be able to take whatever form that number is represented in and create a fraction out of that, or write that as a fraction. So let's look at how I would do that with a terminating decimal. So remember, these are decimals that stop. So this is a terminating decimal. It stops after a while. Alright, so to represent a terminating decimal as a fraction, you're going to count the number of decimal places. You're going to write the decimal without the decimal point in the numerator of a fraction. And the denominator of the fraction will be 1 followed by the same number of zeros as decimal places you counted. And then you might have to simplify to lowest terms. So when I say the denominator of the fraction will be 1 followed by the same number of zeros as decimal places you counted, this is also, or another way we could say this, is that the denominator will be a power of 10. So the denominator is either going to be 10, 100, so it's going to be 10, 100, 1,000, having a little trouble writing with the mouse. 10,000 or so on. So let's look at each of these. It says show that each decimal is a rational number by representing it as a fraction. Alright, so in this one, the first thing I'm going to do is count the number of decimal places. I have 2 decimal places. So I'm going to write the decimal without the decimal point. So I'm going to write 50 as the numerator of my fraction. And then as the denominator, I'm going to write 1 followed by the same number of zeros as decimal places. There were 2 decimal places, so 1 is going to be followed by 2 zeros. Now, this is 50 and 100. We know both of those basically are divisible by 5, 2, 10, right? So we can reduce this fraction. If you need to, or if you have a calculator, a graphing calculator that will reduce the fraction for you, you can go ahead and do that. There are websites that will reduce the fraction for you, but really 50 and 100 have a common factor of 50. So if I divide 50 by each number, or each number by 50, 50 divided by 50 is 1, and 100 divided by 50 is 2. So this ends up being the decimal, or I'm sorry, the fraction 1/2. If you heard that noise, that was just me getting an email. Alright, so let's look at this next one. 0.682. So there are 1, 2, 3 decimal places. So I'm going to write the decimal, or the decimal number without the decimal point over top of 1 followed by 3 decimal places. And I don't know why I wrote 625 when it was 682. Something's wrong with me. So it's 682. I'm not sure why I wrote 625. It's early, I guess. And I noticed that 682 and 1000 are both divisible by 2, so I can reduce this fraction. So I'm going to divide each of these by 2. And I get 682 divided by 2 is 341 over 1000 divided by 2 is 500. I think that's as simple as we can go. Alright, let's look at this last one. So the last one is 425. So I'm going to count the number of decimal places. I have 2 decimal places. So I'm going to write 425 without the decimal point over 1 followed by, since I have 2 decimal places, 2 places after the decimal, I have 2 zeros. So really I have 425 over 100. Now both of these are divisible by 5, right? Because they end in 5 or 0, but it just so happens that they're both actually divisible by the greatest common factor is 25. And we'll talk more about the greatest common factor and the lowest common multiple actually in class. So 425 divided by 25 I think is 17. And 100 divided by 25, I know that's what? That's 4, right? So this is going to end up being 17/4. Alright, so we have actually shown that each one of these numbers are rational numbers. Or I guess each number is a rational number because we were able to represent it as a fraction. Alright? So, fractions and mixed numbers and terminating decimals are all rational numbers. And so are natural numbers, whole numbers, and integers. Alright, let's take a look at repeating decimals. To represent a repeating decimal as a fraction, we're going to use the repetend, or the infinitely repeating digit sequence, as the numerator of the fraction, And the denominator will be a number formed by the same number of 9s as in the repetend. So it's going to either be 9, 99, 999, and so on. And then you might simplify to lowest term. So let's show that each decimal is a rational number by representing it as a fraction. Now this is a trick, actually, that you can use. So in this case, the repetend, or the infinitely repeating digit sequence, is 2, 3. So this repeats 2, 3, 2, 3, 2, 3, 2, 3, 2, 3, 2, 3 over and over again, right? So what I'm going to do to write this as a fraction is I'm going to write 2, 3 over the same number of 9s as in that repeating part, as in that repetend. So there were 2 numbers in the repeating part, so I'm going to write 2 9s. So this is 23 over 99. And if you divide 23 by 99 on the calculator, I guarantee you'll get 0.2323232323. I don't think that can be reduced, so we'll just leave that the way that it is. So what about 0.345? Now this has a bar over top of it, so we know that this is really 0.345. So 345 is the repetend. It has 3 digits in it. So I'm going to write it over 999. And 345 divided by 999, or 345 over 999, those basically, they have a common factor of 3, those two numbers do. So if I divide both by 3, I'm going to get 115 over 333. And I don't think you can reduce that. I think that's it. Now, sometimes you'll have a repeating decimal that has some numbers in front of it before the repeating part begins. So notice here that 5 does not repeat, but I start repeating 6. Right? So I could rewrite this as 4.56 with a line over it just over 6, right? Make that decimal a little bit bigger. So how do I write this as a fraction? This is a repeating decimal, so it's still a rational number. So I should be able to represent it as a fraction. Take a look at the next video, and the next video will show you some examples dealing with writing a repeating decimal that has a non-repeating initial sequence of numbers as a fraction.